Hi, hello everyone. Today we will continue our lesson still in chapter 1 circular measure. Let's start our lesson. Today we will learn about the area of sector of a circle. The first part is determining the area of sector, radius and the angle subtended at the center of a circle. In general, the formula for area of sector is given as A equal to 1 over 2 r square times theta. Okay, how do we get this formula? Okay, look at the first diagram. Using the concept of ratio, the ratio of minor sector A or B to area of circle is equal to angle A or B to 360 degree. Okay, by using this concept, we can derive the formula area of minor sector A or B equal to pi r square divided by 360 degree times theta, where theta is the angle in degrees subtended at the center of circle, or whose radius is r units. However, if the angle is measured in radians, we can replace the value of 360 degree with 2 pi. And then we will get the equation A divided by theta equal to pi r square divided by 2 pi. And then you need to simplify the equation and you will get 1 over 2 r square theta. Now, let us move to the example given. Example 7. Find the area of sector A for each sector MON with a center O. Use pi equal to 3.142. Question A. Okay, to find the area of sector using the formula 1 over 2 times r square times theta, okay, we just replace the value of radius and theta given from the diagram. Okay, so we can get here A equal to 1 over 2 times the radian here is the radius here is 12 centimeters, so we write down 12 square, and the theta here is 1.7 radian. Okay, you just multiply all the numbers and you will get the answer as 1 to 2.4 centimeter square. And then let us move to the second example. You are given the radius here is 8 centimeter and the angle here is 2.2 radian. Okay, we just need to replace the value of the radius and also the value of the angles into the equation. So we will get 1 over 2 times 8 square times 2.2. So the answer is 70.40 centimeters square. And then question C. You are given an angle 124 degree, but this angle is outside the sector MON. So you need to find the reflex angle MON in radians. Okay, first we need to minus 360 degree with 124 degree to get the angles inside. And then we multiply with theta per 180 degrees so that we can change the angle to a radian. Okay, you just substitute the value and you will get the answer as 4.12 radian. Okay, then using the formula to find the sector, the area of a sector, we just replace the value of the radius here, which is 10 centimeter, and the value of radian, the angle here is 4.12 radian, and finally you will get the answer as 206 centimeter square. Now, let us look at this example 8. The diagram on the right shows a sector POQ which subtends an angle of theta radians and has a radius of r centimeter. Given that the area of the sector POQ is 35 centimeter square, find A. The value of r if theta equal to 0.7 radian, and B. The value of theta if the radius is 11 centimeter. Okay, from this question, you are already given the area and you need to find either the value of r, which is radius, or the value of angles, okay, which is theta. Okay, now let us move to the first one. Okay, using the formula of area of sector, which is 1 over 2 times r square times theta, so we just substitute the value here. The formula here is equal to 35. Okay, then we substitute the value of theta, which is 0.7. Then you just need to find the value of r. Okay, so the value of r here is 10 centimeter. And for question B, you need to find the value of theta when you are given the radius. Using the same formula, 1 over 2 times r square times theta equal to 35. Okay, substitute the value of a radius, which is 11. And you will get the answer for angles in a radian. The second part is determining the area of segment of a circle. Let us move to example 9. For each of the following given sectors POQ with center O, find the area of the segment PRQ in centimeter square. Okay, so in this question, you need to find the area of the green region. Okay, the segment. Okay, look at the example, the first example. Okay, in this diagram, you are given the radius of the circle, which is 6 centimeter, and also the angle, which is 2.2 radian. Okay, so to find the area of the segment, actually we need to find the area of a sector first, and then we minus the area of the triangle POQ. Okay. Okay, first I will explain about the area of the sector POQ here. Okay, so we use the formula 1 over 2 times r squared times theta. Okay, we just substitute the value of radius, which is 6 cm, and also the value of the angle, which is 2.2 radian, and you will get the area of sector, which is 39.60 centimeter square. And then we need to find the area of triangle POQ. Okay, since we have the angle, which is 2.2 radian, and also we have the radius PO and OQ, we can use formula of sine to find the area of the triangle. Okay, which is 1 over 2 times OP times OQ. Okay, the length of OP and OQ, and sine POQ. Okay, sine POQ, you need to find the angle in degree. So first we need to convert the angle 2.2 radian to degree. Okay, so 2.2 radian to convert to degree, we need to multiply with 180 degree and divide by 3.142 divided by pi, and we will get 126 degree 2 minutes. Okay, so we replace, we substitute the value of angle here. Okay, and then you find the area of POQ. And finally, just minus the area of sector, which is 39.60 minus 14.56, the area of triangle, and you will get 25.04 centimeter square. Okay, next we move to question B. Okay, for question B, the information given here is a length of OQ, the radius, and also length of OP, okay, which is 3.5 centimeter. And since we have the values of two length, we can find the angle QOP using sine rules, okay, trigonometric rules. Okay, first, okay, if you notice here, below here, okay, the triangle here QOP, okay, we can divide the length of QP into two parts so that we can get the right angle triangle. Okay, we have right angle triangle. Thus, using the sine rule, the trigonometric rules, we can get the angle of QOS. Okay, because if we need to find the angle here, we need the length of opposite and hypotenuse. Then we can find the angle QOS, which is 34.51. Okay, so to get the angle of QOP, you just multiply with 2. Okay, look at this, the right part here. Okay, so to change the angle to radian, angle QOP to radian, just now we have 34.51, 34 degree for 51 minutes. Okay, you just multiply with 2. Okay, and then you will get angle POQ. Okay, and then convert to radian by multiplying with pi divided by 180 degree. Okay, and you get the angle in radian, which is 1.217 radian. Okay, next we find the area of sector POQ. Okay, using the formula 1 over 2 times r square times theta. Okay, r here, the radius here, we already know from the diagram, which is 3.5 centimeter, and the angle here, theta in radian, is 1.217. So we get 7.454 centimeter square. Okay. For previous example, the calculation show the area of triangle using sine rules. Okay. Another way to find the area of triangle is by using Heron's rules. Okay, you have learned this in Form 4 in Chapter 9. Okay, to use these rules, to find the area of triangle by using this rule, you need to find the semi-perimeter. Okay, how to find the semi-perimeter? Okay, so we have the lengths of the triangle, all the lengths. We have 3.5, 3.5, and 4 centimeter. Okay, just divide by you add up all the value of the length and divide by 2 is equal to 5.5 centimeter. Okay, this is the formula, okay, of Heron's rules. Okay, if for those who didn't uh, for those who already forget about this, you can refer back to your Form 4 notes on Heron's formula. Okay, we just substitute the value here, and we can find the area of POQ, which is at 5.745. And to find the area of segment, you just minus the area of triangle POQ from the area of sector. And finally, you will get the answer 1.709 centimeter square. Okay, now let us move to the next part, solving problems involving area of sectors. Okay, let's move to example 10. The diagram on the right shows a paper fan fully spread out. The region P, Q, and M, okay, P, Q, and M here is the region that red in color is covered by paper. Given that OP equal to 15 centimeter. Okay, if we look at this diagram, OP is the radius of the paper fan. OM, the ratio of OM 2MP equal to 2 is to 3. Okay, and the angle of POQ here is 120 degree. Calculate the area covered by the paper in centimeter square. So in this question, we need to find the area of the red paper. Okay, so to find the area of the red paper, we need to find the area of the sector for the whole paper fan minus the area of the sector which is brown in color, MON, sector MON. Okay, first, to find the area of MON, we need to find the length of the radius. Okay, so using the ratio given, okay, we can find OM 2/5 times OP. Why 2/5? Because the ratio of OM is 2. Okay, the total ratio is 5. 2/5 times OP. Okay, OP here is 15. So we get the length of OM is 6 centimeter. Okay, and then to find the area, we need to convert the angles from degrees to radian. Okay, convert 120 degree to radian by multiplying with pi divided by 180 degree. And then you will get the angle 2.0947 radian. Okay, next we calculate the area of sector POQ, the area of the whole paper fan. Okay, 1/2 times r square times theta. Okay, radius here is 15 and theta here is the angle given in radian that we just calculate just now, which is 2.0947, and we get the area for the paper fan 235.65 centimeter. Okay, then we need to find the area of sector MON. Okay, this area. Okay, so now so just now we know the length of OM is 6. So we just substitute the value of 6 into the equation using the same angle, and we get the area for sector MON is 37.70 centimeter square. So we know the area covered by the paper. Okay, we just minus the area of MON from POQ, and the final answer is 197.95 centimeter square. Okay, that's all for today's lesson. And as usual, you need to complete your assignment. The formative exercise 1.3 from textbook page 19. Okay, till we meet again for the next lesson.